Hello students. So today I'm going to discuss test for phenols, and one of the test is neutral FeCl3 test. What happens when a phenol is treated with neutral FeCl3? We obtains a violet color, water soluble complex is formed. See, the chemical change which takes place here, it is C6H5OH thrice plus FeCl3. Here it's neutral solution, and we obtains this is a violet color, water soluble complex. It is ferric triphenoxide. Generally, some other compounds also gives this positive neutral FeCl3 test. Those compounds which are having enolic group. So compounds which are having enolic group means it is this. They gives a positive neutral FeCl3 test. We will discuss one more test here, and that one is LIBERMANN NITROSO test. Most of the phenols gives this test. What happens here? When a phenol is treated with NaNO2 and concentrated H2SO4, we obtains a red or brown coloration is obtained. And if we add some alkali in it like NaOH, so this red coloration turns blue or green. So this confirms that the compound given to us, it is phenol. What chemical changes occurs here? See, this NaNO2 reacts with H2SO4, and here we obtains a nitrous acid along with NaHSO4. See, nitrous acid is not very stable, and that's why in the reactions where HNO2 is required is always prepared within the reacting vessel by the reaction of sodium nitrite and some acid. Now here it is phenol molecule. Now this phenol reacts with the HNO2. The hydrogen from the para position comes out with the OH in presence of concentrated H2SO4, which is a well-known dehydrating agent too. Here water molecule sits free, and this carbon will form bond with the NO. See, we will get here our nitrosophenol is obtained. This nitrosophenol rearranges see, the pi electrons of this NO bond shifted over the oxygen. Now this nitrogen itself becomes electron deficient. So these pi electrons shifted in between the ring and nitrogen. Now in order to compensate deficiency of this carbon, these electrons shifted here. And finally, to compensate the deficiency of this carbon, the OH bond electron shifted in between the ring and oxygen. See what happens here. Now as these two electrons shifted in between the ring and oxygen, so double bond will form here. Now as these two electrons shifted to this place, here double bond will form. And this electron shifted in between the ring and nitrogen, double bond will form here. And now as the pi electron of NO bond shifted over oxygen, so single bond will remain here. Now as the two electrons comes over oxygen will become negative charged. So the H plus which sets free from the another end will form bond to this oxygen. This is also our nitrosophenol, but this one is its quinone form. Now the quinone form of the nitrosophenol this reacts with the phenol molecule. See, as the reaction occurs in presence of the concentrated H2SO4, so again the para hydrogen comes out with the OH in the form of water. And see, nitrogen has broken one bond, ring has broken one bond. So a new bond will form in between the ring and nitrogen. Here it is OH. So the compound this formed, this is called endophenol. And this endophenol is of red color. See, in this compound, in endophenol, this quinone is a chromophore part. So due to this chromophore part, it producing a red color. Now, when we add an alkali here, so this endophenol is acidic in nature due to the presence of this active H. So on adding NaOH, here the H plus sets free with the OH minus of the alkali in the form of water, and we obtains here sodium salt of endophenol, and this one is blue. So this chemical reaction occurs, and if a compound on adding with NaNO2 and concentrated H2SO4, red coloration is obtained, and that red coloration turns to blue or green on adding an alkali. So this confirms the compound is phenol.